The United States is preparing to send humans back to the moon. Artemis II is on the pad, 4 astronauts are in training, and for the first time since 1972, American boots may soon travel toward the lunar surface. But here is what makes this moment different from every moon mission before it. For the first time in American spaceflight history, there is a genuine competitor moving on a parallel timeline toward the same destination. China has confirmed it is on track to land astronauts on the moon by 2030. Its hardware is built, its timeline is published, and its track record of hitting stated milestones is better than most Western analysts expected. The question we need to sit with is whether NASA is moving fast enough to matter. Artemis was designed as a structured return to the moon. Artemis I, an uncrewed test of the Space Launch System and the Orion capsule, flew successfully in late 2022 and proved the core architecture worked. Artemis II was supposed to follow in 2024, then slipped to 2025, then to February 2026. A liquid hydrogen leak during the wet dress rehearsal in February pushed it again. A helium flow issue then triggered a full rollback to the vehicle assembly building, and the launch was delayed to April 2026 at the earliest. As of late March 2026, Artemis II has rolled back to the launch pad and is targeting its first attempt in April. What we are watching is a program that works in pieces but struggles to hold a timeline end to end. Each individual system, the SLS rocket, the Orion capsule, the ground support infrastructure, performs when it performs. But the integration of all of them into a launch-ready configuration has proven consistently harder to schedule than NASA's public estimates allowed for. To be clear, delays in complex spaceflight programs are expected. Apollo had them, Shuttle had them, and the International Space Station was years behind its original schedule. The pattern is familiar. What makes Artemis different is the context in which those delays are occurring. We should understand what Artemis actually is before we assess what its delays mean. Artemis is a full architecture, the SLS, the Orion crew capsule, the Lunar Gateway Station planned for lunar orbit, the human landing system, and the surface systems needed to sustain astronauts once they get there. Every one of those components is on its own development and testing schedule, and every one of them has to work together before a crewed lunar landing is possible. That interdependency is where compounding becomes a real risk. When SpaceX's Starship, which serves as the human landing system for the crewed lunar landing, experienced 3 consecutive failures during 2025 testing, the landing timeline moved. NASA's acting administrator responded by reopening the landing contract to accelerate alternative proposals and by naming a new associate administrator specifically to drive the Artemis III timeline forward. Blue Origin's Blue Moon lander, which had been a secondary option, is now more directly in play. The first robotic Blue Moon flight is targeting 2026. A second flight carrying NASA's Viper water ice rover has been tentatively selected as a stepping stone toward crewed operations. As of March 2026, NASA has also announced a structural change. An additional uncrewed test flight will be inserted into the sequence before a crewed lunar landing attempt. The first crewed landing, what was previously called Artemis III, is now expected no earlier than Artemis IV or V, with 2028 as the current target. What was a 4-mission path to the surface has become a longer one. For most of Artemis's existence, its biggest obstacles were political and budgetary. The FY 2026 budget, proposed by the Trump administration, included a roughly 25% cut to NASA's overall funding, the largest proposed reduction in the agency's modern history, and the agency spent nearly a full year without a confirmed administrator. But in 2025, the competitive pressure became concrete. On October 30th, 2025, a spokesman for China's crewed space program stated publicly that the country is on track to land astronauts on the moon by 2030. That confirmation landed in front of U.S. Senate hearings, where former NASA Associate Administrator Mike Gold told lawmakers, "The countries that get there first will write the rules for what we can do on the moon." The timelines of both programs now sit close enough together that this has become a live scheduling question. Let's look at what China is actually building. The Lanyu lunar lander completed engine testing in 2025, and the Mengzhou crew capsule is scheduled for its first uncrewed flight in 2026. 2026, followed by the Lanyu lander in 2027. A joint test mission combining both systems is planned for 2028 or 2029, with Chang'e 7 launching in the second half of 2026 to survey the lunar South Pole for water ice. China is executing this plan on a published schedule, with hardware already in testing and a confirmed crewed landing target of 2030. We need to be honest about what the US is trying to build, because its ambition is part of why the timeline is what it is. Artemis is designed for sustained presence on the Moon, the kind that enables repeated missions, resource access, and long-term scientific operations. The Lunar Gateway, which will serve as a staging point in lunar orbit, is intended to support repeated missions over decades. The commercial lander model, with multiple companies competing to provide surface access, is intended to create an ecosystem of capability that distributes cost and development burden across the private sector. That architecture, if it works, is genuinely more valuable than a single crewed landing. The problem is that building it takes longer than building a single-path system. China's approach is more direct, fewer moving parts, a centralized decision chain, and a clear target date. Both approaches make strategic sense on their own terms, and only one of them is currently on schedule. One of the most consequential decisions in Artemis's history was the selection of SpaceX's Starship as the human landing system for the crewed lunar surface mission. That decision made Starship's development timeline inseparable from NASA's own. Starship, if it works at the scale NASA needs, transforms lunar access entirely. The vehicle's payload capacity and reusability would change the economics of operating on the lunar surface in ways no previous system could. Starship's development timeline is NASA's timeline. 3 consecutive testing failures in 2025 made that dependency visible in ways that earlier projections had not fully accounted for. NASA's response, opening a parallel track with Blue Origin's Blue Moon lander, is sound risk management, though parallel tracks cost time and money, and both are under pressure from the current budget environment. What we are seeing is the core tension in NASA's commercial model. It delivers innovation and scale at a pace a purely governmental program could not match, and when a commercial partner's timeline slips, the mission timeline moves with it. The rewards of getting this right are substantial. A sustained American presence on the lunar South Pole, where water ice makes long-term habitation viable, would give the United States the ability to shape how the Moon's resources are accessed, governed, and used for decades. The Artemis Accords, which 61 nations have now signed, establish the framework for how partner nations operate in that environment. The country that builds the infrastructure those 61 partners depend on will hold leverage that a single mission could never provide. Let's be specific about what that leverage looks like in practice. The lunar South Pole contains permanently shadowed craters where water ice deposits sit undisturbed. That ice, processed into hydrogen and oxygen, becomes rocket propellant that makes the Moon a refueling depot for missions deeper into the solar system. Whoever builds the extraction and processing infrastructure first sets the operational standards, the access conditions, and effectively the terms under which every subsequent mission operates in that environment, which is a strategic position worth considerably more than a single crewed landing. The deeper risk for the United States is arriving second. If China establishes a sustained presence on the lunar South Pole before Artemis infrastructure is operational, the terms of access, the governance frameworks, and the practical question of which systems everyone else must be compatible with start to be answered in Beijing. Former NASA Associate Administrator Mike Gold said it plainly to the Senate, "Whoever gets there first writes the rules." We are now close enough to both timelines that this is a live scheduling problem, and the gap between them is narrowing. The United States still has the capability, the partnerships, and the technology to lead the next chapter of lunar exploration. Artemis II, when it flies in April 2026, will be the first time humans have traveled toward the Moon in more than 50 years. That is a genuine milestone, and it matters. What we need to ask is what comes after it, and how fast. China's lunar program is state-directed, centrally planned, and immune to the political winds that have repeatedly restarted American lunar ambitions since Apollo ended in 1972. It has a target date of 2030, and a track record of meeting its commitments. NASA's crewed lunar landing, now targeting 2028 under a restructured mission sequence, sits within a few years of that window, with less margin than it once had. The original Apollo program shaped the terms of space exploration for half a century, and the decisions being made in this decade about which that systems get funded, which timelines hold, and which programs reach the surface first will shape the next half-century in the same way. The moon has moved from aspiration back to competition. This race is actively being decided, and the outcome is genuinely open.